Today we're looking at lesson 1-6 for geometry on two-dimensional figures. So I've put this up here so that you could look at what I'm talking about, but a two-dimensional figure is a polygon, basically. So you can have a figure that's a polygon, or you can have it not be a polygon. They've shown you some examples here of polygons and not polygons. Notice the difference between the two. Polygons are going to be closed, so they're not going to have any openings like this figure does. They're going to be straight lines, so there's not going to be any curved lines like this figure has. The sides all have a common end point, and each side intersects exactly two other sides. So it wouldn't be something like this, where it's intersecting more than two sides. This would be a curve, that's why it's not a polygon. Same with this one. And then this, there is one intersection but more than two sides intersecting. So that's why all of those would not be polygons. And then there's an example here at the bottom of a convex polygon versus a concave polygon. And basically how I remember it is, if you look at the concave polygon, notice that it has a part in it where it's caved in almost. So one of the sides caves in. That's how I think of it as a concave polygon. The correct wording would be that some of the lines pass through the interior if you were to extend all of the sides. But the idea is if it looks like it caves in a little bit, it's concave. If it's not, then it's convex. Here are different types of polygons that you could name. There's irregular and there's regular polygons. Regular polygons, all that means is that they have all of the same angles are the same and all of the sides are the same. So they've labeled this pentagon here as regular because you can see all those dashes on each side represent all the sides being the same, and all the angles with the little squiggles on them represent them being the same. So this would be a regular pentagon, or you could say an equilateral and equiangular pentagon. Okay, and then they have all the different types of polygons here, and notice they're based on the number of sides. So we're going to name each polygon and by its number of sides, and then classify it as convex or concave, and regular or irregular. So if you look here, you've noticed that this is obviously going to be convex. There's no part where it's caving in. It is going to actually be irregular because, yes, two of the sides are the same and then the other two sides are the same, but not all four sides, even though all four angles are the same. So we can't say that it's regular, it has to be irregular. And this has four sides, so we call it a quadrilateral, which is four sides. And if we look back at the table, whoops, here, you can see that four sides means quadrilateral. So this would be a convex, irregular, quadrilateral. The next one, notice that all of the sides are marked with the same dash and all of the angles are marked with the same. So this is going to be a regular polygon, but notice that each of the sides caves in. So this is a concave regular polygon. Now we need to count how many sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 sides, so we go back to our chart. 10 sides says decagon, so we're going to put this as a decagon. Next one, notice again you have all the sides are labeled the same and all of the angles are labeled the same, so that makes it regular. It's convex, however, because none of the sides cave in. So it's convex and regular. We just need to count how many sides there are. 1, 2, 3, 4, 6. So that's going to be a hexagon. Here we're finding the perimeter and area. Sometimes you call the perimeter circumference when you're dealing with the circle, but the perimeter and area, or the circumference of these figures. So we're going to use these formulas to find. So this is asking us to find the perimeter or circumference and area of each figure. So this figure is a rectangle because one side is a little bit different than the other, even though it looks similar. So a rectangle formula for the perimeter is 2L plus 2W. And what that means is 2 times the length plus 2 times the width. So it really doesn't matter whether you put in the 6 as the length or the width, because both are being multiplied by 2. But we're going to plug in 6 for the length and 5.5 for the width, and we're going to solve. So order of operations, we need to do multiplication before addition. So we get 12 plus 11, and that gives us 23. And it's labeled as feet, so that's our perimeter. Our area is going to be length times width is the formula. So all we're going to do there is multiply 6 times 5.5, which gives us 33. And area, we usually square the units, so we get feet squared. The next one is a circle. The circle circumference formula for a circle is considered its perimeter. So the circumference formula, you can either use 2 pi r or pi d, depending on what you're given. So this one we're given the diameter, which is all the way across the circle in the center. Sometimes if you're given halfway across, which is the radius, you can use the top formula, but we're going to use pi times d. So pi is going to be represented as 3.14 times our diameter, which is 6.2. So we multiply that, 3.14 times 6.2, which gives us 19.468. And we're labeling that centimeters. Since it didn't tell us to round, we just leave it as the full decimal and label it with centimeters. That's the perimeter, or the circumference of the circle. Then you do the area, which is pi r squared. So think of the radius as half the diameter. So to find r, we would think of half of 6.2, which is 3.1. So we're going to do pi times 3.1 squared. Exponents comes before multiplication, so 3.1 times 3.1 gives us 9.61. So we're going to do pi times 9.61, or 3.14 times 9.61, which gives us 30.1754. And that's going to be labeled with centimeters squared for area. The last figure is a triangle. The perimeter of a triangle is adding up all 3 sides. So side plus side plus side. In this case we have our 3 sides are 10.5 plus 9.5, and you actually have another plus 9.5 because 2 of the sides are the same. So we add that up to give us 29.5, and we label that with inches. And the area of a rectangle is base times height divided by 2, or sometimes you'll see half times base times height, same thing. So the base in this case is the 10.2. So 10.2. And our height is actually not the slant height, the part that slants. It's going to be the straight up and down height from the vertex down to the base. And that's our 8. So we're going to do 10.2 times 8 divided by 2 to give us 40.8. And again, label that with inches squared. And then the last problem, or second to last problem, is we're trying to figure out what is the best type of space that we need to create this fence around. So we need to figure out, it says that this guy has 32 feet of fencing to fence in a play area for his dog. Which shape of play area uses most or all of the fencing and encloses the largest area? So really they're asking for the largest perimeter and largest area. So we need to figure out of these 4 options which one gives us the largest area. I would do that first. So if we do each area formula, we have circle for F, that's going to be pi r squared, and our radius is 5, so 25 times pi. That gives us 78.5, so keep that in mind. Then we do a rectangle with a length of 5 and a width of 10. The area to do that is to multiply 5 times 10, which gives us 50. Keep that in mind. Then we have a right triangle with legs of 10 feet each, so that means both legs are 10 feet, or the base and the height are 10 feet. So that's going to be 10 times 10 divided by 2, base times height divided by 2, which is also 50. And then a square with a side length of 8. The area of a square is just the side squared, so 8 times 8, and that gives us 64. So the part with the biggest area, and we can assume then the longest perimeter, is going to be F. F, the circle. Now, the last one, we need to think of this on a graph. So we're going to find the perimeter and area of this triangle. So we need to use, instead of rulers or lengths and widths, we need to actually use the distance formula to find these parts. So if we're getting a triangle with A, B, and C, those are its points. We need to do 3 sides, so we need to do 3 distances. So we're going to need to do, if you want a better picture, maybe we'll graph it. This is -1, 4. That's A. And then -1, -1. That's B. And C is 6, -1. And that's C. Okay, so we have A, B, C. If we connect it, we actually have 2 sides there given to us that we can just count because they're straight up and down. They're vertical and horizontal, so we can just count the units instead of using the distance formula. So that would give us 1, 2, 3, 1, 2, 3, 4, 5 for this side. And then 1, 2, 3, 7 for this side. Okay, if we want to just do it by hand. So that means the perimeter, we're going to do 5 plus 7, but then we need the last side. Now the last side is the issue because you need to use the distance formula when you have a diagonal line. So we're going to find the distance of AC. If we go back to the points That's going to be using -1, 4, and 6, -1 in the distance formula. So if we plug that in, subtract the y's, subtract the x's, square them, add that to subtract the y's, and square them, and we get -7 squared, which is 49, plus 5 squared, which is 25, and we're going to do the square root of that, which gives us 74. So the square root of 74. We can just leave that in terms of square roots, but that's what this side length is going to be. So this is going to be 5 plus 7 plus the square root of 74. And that's units, since we don't know the units. So that would be our perimeter, or you could simplify it a little bit more, 12 plus the square root of 74, like that. And our area of a triangle is base times height divided by 2. And we know our base and our height was 5 and 7, so we can just multiply 5 times 7 and divide that by 2. 35 divided by 2, which gives us 17.5, and this we're going to label with units squared. And that concludes lesson 1-6 for geometry on two-dimensional figures.